Hello and welcome to part 2 of our 3-part series, Getting into Scanning, where we will look at scanning best practices. If you missed our first presentation, I recommend going back and looking at that, as we'll be continuing on from that presentation in this one. The first presentation looked at the basics of scanning in general, where we covered different types of registration and some of the terminology used when we're looking at scanning. The next presentation will be looking at continuing on from what we've discussed, where we will look at the office capabilities and processes for scanning data. Practices discussed here are relevant to all scanning projects and manufacturers. However, Trimble scanners will be used and software throughout the presentation. The issues identified in this presentation are considerations that are needed for all scanning projects. As scanning needs to have a heavy reliance on field practices, it's recommended to look at a scanning job before going out into the field to make sure that you're using the correct processes and procedures in the field to collect all the data that you need. As poor field practices will result in incorrect data being collected, errors being introduced into the data, or data being missed where it needs to be. This process will primarily focus on cloud-based registration, as it is the one that it's the easiest to do. However, it can have the most impact on your results. However, the items discussed are relevant to all scanning types. So let's look at scanning in general. Scanning locations and what it needs to collect needs to be considered when setting up a scanning project. The instrument can only capture what it can see at any given point, and it should be noted that shadowing behind objects needs to be a consideration in what is being collected. If you are seeing shadowing in data, it may be necessary for you to move the scanner to a new location to capture the data behind if it's relevant to what you're picking up. When you're shifting to a new location, it's always important to make sure that all objects are picked up in the scan that can be at that location, and it is in the best spot to achieve your results. Adding scans between setups that aren't registering properly or where data has been missed isn't a big deal, particularly when looking at instruments such as Perspective, and office processes can be used to fit those scans back into the registration set to ensure that they all fit together properly. For long linear projects like roads, it's recommended to occasionally alternate sides of the road to get better coverage and combine it with different processing and capture techniques to achieve the best results. Don't set up directly underneath power lines and objects that need to be picked up. Make sure that things are offset slightly to achieve the best results as well. Another consideration when scanning is that the scanner will not pick up data within a minimum range. So setting up within a doorway may result in some areas not being captured. So it's important to note how your scanner works and functions, what the minimum and maximum distances are when going out and when looking to set up a project. Scan distances are an important consideration. The greater the distance between the scans, of course, the faster a project can be captured. However, this will impact on the number of points that are picked up, and it'll have a significant impact on how well data is registered. Wherever possible, it's recommended to have closer scans together rather than scans further away. And sure, you can come back and fit scans in later if necessary to help the registration process, but it may not be as simple as that, and you may need to go into the office to identify where scans are missing to go back out and recapture the data. For general jobs outside and long projects, 30-meter distance between scans is the maximum distance that you would probably look at doing. Even that's probably at the far end. And when looking at cloud-based registration, be aware that the further the scan data is apart, the less scan information is between the scans, and the potentially poorer the results will be for registration. This doesn't mean that you need to do a scan every 1 meter either, but there is a sweet spot in between where time and the amount of data captured will achieve the best possible results. And this will generally be dependent upon the type of project and what is being captured. Control marks throughout scanning projects are an important consideration too, as they can be used as reference to georeference the data. However, they can also be used as checks along the scan to make sure that the data is captured and that no errors have been impacting greatly on the location of the data. Any identifying marker can be used as coordinates as long as it can be seen in scan data. However, it is recommended that control points are a 3D point and not just a horizontal location, as vertical shifts can occur as well as horizontal shifts. Survey targets and spheres and GCPs are recommended as they are identifiable in the scans, and generally when you're turning on intensity values in the scan, they will come up and you can see them quite easily. Control points should be picked up with the same name in the field as they are in the office for instruments that can do that, such as Perspective, to make sure that it's easy to identify what control point is what has what coordinates in the scan data, and to also help automatically identify those control points. When we're using control points here, we're not necessarily talking about target-based registration. They can be used for target-based registration, but when looking at general scanning practices, control points are used to identify how close you are to the marks that you're looking for and to ensure that you are retaining some form of quality control as you go through a project. Leveled scans are preferable, however not essential. Leveled scans generally take a little bit longer. While only minute, they can take a little bit longer than an unleveled scan. At a minimum, it's recommended about every 8th scan is a leveled scan to ensure that you're returning to some form of level and that the scans, any errors aren't being shifted all the way through the scan data. There are cases where no leveled scan data at all is preferable over having 1 or 2 leveled scans in a long or a large number of scans. These cases can be addressed in the office. However, it is recommended that at least 2 leveled scans should be in a registration set as well, particularly at the start and the end, to make sure that the data is at a level area. Leveled scans are held at a constant for level in both Perspective and Office processing software in the Trimble environment, and also most external environments as well. Errors in cloud-based registration will affect results if leveled scans are few and far between. And as mentioned, a single leveled scan can impact the entire registration set in Office software. So let's look at the registration and best ways of doing that out in the field. The processes discussed here need to be a consideration for all scanning projects. Most processes discussed will be done in the Office software once the field data has been downloaded. It's essential to understand the best registration process and also different registration techniques and what to look for when registering the data to achieve the best results. This section of the presentation will be looking at the Trimble Perspective and X7 setup. However, again, this workflow can be considered for all different types of scanning. The number of scans is an important consideration when looking at all scanning projects. Scanning projects generally allow you to do any number of scans. However, there can be limits on the number of scans that software can be used. And there are also times when limiting the number of scans will help achieve a better result. Maybe it's better to create a different scan project for different floors of a building, for example, rather than having one single scan project for all floors. When looking at Trimble Perspective in particular, it's recommended that no more than 160 scans are in a single project. Any more than that, the tablet does not necessarily achieve its full capability, and you may have difficulty getting that data off the tablet. If you're doing colorization out of Trimble Perspective on export, it's recommended that no more than about 120 scans are done in this process. Again, the colorization process can be done in the Office as a secondary step, so it's not as essential. However, it is a consideration that needs to be made. And if you're exporting to a third-party format, such as Recap out of Trimble Perspective, it's recommended that no more than about 80 scans are done. And be aware that the colorization and refinement step, and also the exporting to a third-party format out of Trimble Perspective can take time depending upon the number of scans. So there are cases where it is recommended that different projects are used as opposed to doing one single project with a lot of scans to help speed up these processes. The calculations above are done on a 2-minute scan with the X7. If you're using a higher detail scan, then there should be less scans in the project. Another consideration is that scans of internally in a room will generally collect more points than an open air scan, and you may find that you could get more open air scans in a project and less internal scans in a project. However, these are rules of thumb and should be looked at when setting up generally. Perspective cannot export a subset of scans from a project. So if you go over these limits, we will have to get the raw data off the tablet and manually join the scans together or manually process the data in a third-party package, which can be done. However, it is recommended that the field processes are done as best as possible from the get-go. When looking at perspective and general scanning processes, it is always recommended to do a visual check. The reason for this is that when you're registering scans together in particular, they're based on an algorithm, and while the system may tell you that it has passed that check, it may not actually have done it properly, and what it's based its checks on may not actually be telling you the whole story. So it's always recommended to ensure that a visual check is done before moving forward. In perspective in particular, you can break out scans that have been mismatched and you can re-register them together using one of the different techniques that are done. The thing to look for in scans is that things like power poles and signs and buildings, even trees to a degree, curb and gutters are all matching up. In the case here on the right, you can see that the signs and the power poles have ghosting, be it that there are multiple instances of that right next to each other in the scan data, where in fact there should only be one version of it. In the field, this should be addressed before moving to the next scan to help minimize that being an issue moving forward. In the office, this would mean that you would need to break the scan apart and re-register those scans back into one another to ensure that it is matched up correctly. If this isn't picked up in the field, the third scan that is joining back to the first two scans may not actually pick the correct points that you are looking for, and you may start to accumulate some large errors further on through the project at particular points. Remember, for a long linear project, say 20, 30, 40 scans, if this is done at the start, while it seems small at this particular point, when it's collected and moved through the entire scan, that error can have large impacts later on. Before doing a final registration of the data in perspective and an output, it is recommended to just check through all the data one final time before processing it to make sure that it all matches up correctly and addressing any errors. Registration issues should be addressed as they happen, as mentioned previously. This helps additional scans registering along the project and may mean that you don't need to do so much work in registering the scans as you go through a particular project. Processes for overcoming the registration are adding another scan between two scans that have a low quality match, or where there's minimum data in between the two scans. It's relatively quick to shift the scan into a black point or a dead point and add more scan data to improve the quality of the registration between two scans, which will help the project moving forward. The other one is that you could use 2-point registration to manually select 2 points in each scan that are common areas to help the system identify where it should be matching the data up against one another and producing the best results. In the example on the right, scan 29 and scan 30 didn't correctly match to one another, so scan 31 was put in between the two to help improve the registration process. Wherever possible, scans should be broken up into smaller registration sets. The reason for this is if you have a single long registration set, the error that's accumulating will accumulate through all of the scans. So the longer the registration set, the further the error is being carried and accumulated. If you break it up into smaller registration sets, you can also look at specific areas and identify where more error may be accumulating and only look at a specific area rather than having to check through the entire registration. The more scans in a registration set, the more error that will be introduced and carried throughout the project. Landmarks, buildings, faces, edges, roundabouts should be considered as start and end points of registration sets. So in this case, you would start a new registration set moving forward from a particular area. In perspective, you can create a link to a new registration set. So you could go from scan 30 to scan 31 and then take scan 32 and link that to scan 31 and then break the link between scan 30 and 31 to have two individual registration sets where you have 1 to 30 and 31 and 32 onwards is a second registration set. Those two scans will still be joined together because they were positioned together originally. You've just removed that particular link to create a new registration set moving forward. The problem can be contained to local sections when you are looking at individual registration sets. And it also means that when viewing the data, you can turn off a single registration set to make it easy to identify a single section of the data. Refining the registration is the last step. A refinement is when the process looking at joining all the scan data together. When you're looking at a registration between two scans, you're looking at scan 1, scan 2, scan 3, and how scan 1 links to scan 2, how scan 2 links to scan 3, and so on. The refinement will look at all the scans and how best it fits together. The refinement process is done against the entire project, and you're not looking at individual registration sets, particularly in perspective at this stage. Refinements should not be done until all the shadowing and registration issues are addressed. This process will consider all the point cloud data that is in a project. Projects around buildings will consider the data as the first and last scan and help address misclosure issues in this refinement process. And generally, misclosures to within a certain degree will be closed up as long as they're close enough. There are cases where the distance of misclosure may be too great and it won't work, in which case there may be something else impacting that project and it should be addressed. Refinements can be run multiple times as well. So this means that if you've run a refinement and it gets close, you may be able to run the refinement again to just tighten up the entire network before exporting to make sure that it's as close as it physically can be. Georeferencing the data in perspective is another thing that should be considered. In perspective, you can go through and attach annotations or precision points throughout a scan data, and you can give those a name. Those points can then have a set of coordinates attached to them, which can be imported into perspective as a CSV or another supported format. It should be noted that this is not limited to perspective. This can be done in other packages in the field and in the office as well. And it's worth picking up particular points in the scan data as you go through to make sure that there are annotations or notes against them to make them easily identifiable later on. If this can't be done, say where the corner of the building has been measured using a total station and you have scan data that you're trying to match up to, it is worth noting to take some form of note down to pass on with the scan data, as you may not necessarily be processing the data yourself. In perspective in particular, the georeferencing process does not shift the control of the point clouds. It does not is not considered as a registration process. It is merely fitting the control to the coordinates that are brought in, and it will give you a best fit output from this. So we are not shifting each of the scan data to match the control. This is merely just making sure that it's georeferenced and residuals will be returned, showing you how close those points are to the control from the scan data. When looking at the Office software, looking at Trimble RealWorks in particular here on the right, there is a good report that comes out, and once you run a refinement in Trimble RealWorks, the same with in Business Center, you will get a registration report, and that registration report will give you detail on all the scans that have been linked to, where they've been linked to other scans and how close they are. This is a good indication of how close scans are linked, and anywhere that there are reds or yellows within the outputs, or anywhere that there are high values that are out of tolerance, should be considered as areas that need to be checked within the data to make sure that the matching is correct. As mentioned previously, RealWorks is needed to do target-based registration to achieve better survey grade accuracies. TBC can be used to scale and georeference the data, which is something that cannot necessarily be done in Trimble RealWorks. And refining should be done for all scanning projects in the Office software before use, even if it is done in the field. When looking at particular Office software, the Trimble Business Center should be used for point and line outputs, or 2D outputs where you are georeferencing and joining it to others. Survey data, for example, whereas RealWorks should be used for 3D modeling outputs where you're looking at going to BIM models or other IFC models and doing that sort of workflow. So let's look at a case study. This is a case study that is surrounding a building in Sydney that 96 scans were done as a single registration set, essentially being treated as a long linear scan project. While it was done as a loop and it comes back onto itself, you can't join the end back into the start of the project. This is done through the refinement step when registering data. So it is still considered as being a long linear project. The only consideration here is that because you have a loop and that refinement process does come back onto itself with scanning points, the whole network can be tightened and adjusted according to all the data considered. Control points were used throughout the project as a georeference and to check against to make sure that the data was matching up correctly. When the scan was done originally in the field, it had a 13-meter misclosure comparing the same location from the first scan and the last scan that was done. So this highlighted a couple of issues that needed to be addressed in the field, and a 13-meter misclosure is significant for this particular type of project. Well, for any project really. The large amount of scan data used in the setups in that start and end point was significant, making it hard to identify what was particularly going on. In this area, there were several scans, which made it hard to identify which individual scan was having the most impact on the area. So scan 1 was isolated, and one of the last scans, scan 94, was isolated to compare against. And within these scans, 2 points were measured against. So there was a window that was measured between the green and the red scans, which showed that there was 11.53 meters difference, and 2 roof points were measured that should have been the same point, returned a 13.29 meter difference. And that was a 3D measured distance, not a horizontal or a vertical difference. When looking through the scan data, the first step we would take would be to identify any potential issues throughout the project. And when stepping through the project, it was identified that there was ghosting that had occurred between a couple of the scans in the project. So in scan 11, there was some ghosting that had occurred, and also scan 28. Now, to fix this problem, the scans were broken in perspective and re-registered using the 2-point registration and the manual registration type, and this allowed the scans to match up correctly, and it helped to remove a significant part of the error. One thing to note here is that there was not 13 meters of error that accumulated between these two particular projects, these two cases where there was a mismatch of the data. It may have accumulated at most to 1 meter difference between the two scans. However, as they were at the start of the scanning project, the error had propagated through and we were left with a large difference at the end. After fixing the misclosure between those two scans, the window was now 0.7 meters out and the roof points were 1.2 meters out. And we significantly removed a large portion of the errors. However, there is some of the error still there. The next step that was undertaken was a refinement, and the refinement process matched the scans up. In this particular case, the refinement was done twice, and once the refinement was done, you can see that the overlay of the two scans meant that we're not measuring significant differences anymore. And to measure the differences, we would be needing to look at the refinement report rather than a visual check as what we had been previously doing. When looking at scan data that is properly refined, you can see here the green and the red, there's a large amount of overlap between the two, and this is generally an indication that the two scans have matched up. Once the refinement was run, the project was then georeferenced. So the points were imported into Perspective that matched up with the points that were picked up in the scan data. These points were measured using, say, GPS previously. And when they were matched up, there were significantly more points imported than were collected in the field. However, only the points that were needed were matched together from the imported data. And it was seen that there was a 19 mil error in the scan once the results had come through overall. At this stage, the project was colorized and exported from the tablet for use in other software packages. After importing the data into Trimble RealWorks, the overall cloud-to-cloud error was 1.74 millimeters after a registration was done against all the scan data. This registration refinement was a single process that is just the last step that you would get to get that registration report, and that is why we have got a smaller output from the Office software compared to the field tablet. The cloud-based registration had issues in the field leading to large errors in the results. These errors could have been picked up as the scan was being done. However, they were identified in the end anyway due to the misclosure that was seen at the last 2 points. The issues were fixed in the field software, but they could have been fixed in the Office software as well, using the different tools that are available in Office software, resulting in a significantly better result that fell within a desirable range for the output. Cloud-based registration was a good tool to be using in this particular project, and it did produce very good results. The scanning setup process and techniques need to be considered when undertaking large scanning processes, and it's always worth noting that when errors do occur, it's worth going back through and looking through each of the individual setups and the reports that come out to make sure you can see where errors are accumulating and what is going on within a project. Thank you for listening to this this presentation. There is one more presentation to come looking at particularly Office software processes. For more information on scanning projects or queries regarding scanning projects, please contact UPG on 1800 800 874. Thank you.